This is often called the largest cat in the world. It's a creature that can dwarf both its lion father and its tiger mother, a real-life giant made possible by human hands. It's called the liger. But how can an animal grow so much bigger than its parents? How can the child of a 500-pound lion and a 400-pound tiger weigh in at over 900 pounds? The answer isn't magic, it's a fascinating genetic story, a quirk of evolution that, when mixed and matched, creates these incredible animals. Today, we're getting into the science of the liger, and the big scientific and ethical questions that come with them. So, what happens when you cross the king of the savannah with the solitary hunter of the jungle? You get a biological puzzle, an animal that doesn't exist in the wild, yet here it is, seemingly breaking nature's rules. But the secret to the liger's enormous size isn't just about mixing two species. It's a complex genetic inheritance called genomic imprinting, and it explains everything. Stick around as we explore the science that makes the liger a giant, and why its very existence is one of the hottest debates in the animal world. First, let's get our terms straight. A liger is the hybrid offspring of a male lion and a female tiger. They are absolutely real, but they only exist in captivity. Now, if you flip that pairing, a male tiger and a female lion, you get a totally different animal, a tigon. This difference is everything, because it's the key to the whole size mystery. While they're both lion-tiger hybrids, they are worlds apart in size. Ligers are famous for their gigantism, often weighing over 900 pounds, 400 kilograms, and stretching more than 10 feet long. The most famous example is a liger named Hercules, who holds a Guinness World Record for being the largest living cat, weighing in at 922 pounds. Tigons, however, are usually about the same size as their parents, and sometimes even smaller. They rarely get bigger than an average lion or tiger. So what's the deal? How can the same two species create such different results just by swapping the parents? The answer isn't in which genes they get, but in how those genes are used. The main reason for the liger's massive size is a genetic process called genomic imprinting. Think of it as a form of genetic memory, where some genes behave differently depending on which parent they came from. For most traits, you get a working gene from each parent. But with imprinted genes, one of those copies is silenced or turned off. For lions and tigers, this has a huge impact on growth. Let's break it down. Lions live in prides, where a lioness might mate with several males. Because of this competitive environment, the male lion's genes have evolved to be aggressive about growth. His genes basically say, grow big, grow fast. I want my cub to outcompete any other cubs. These are growth-promoting genes. But the lioness has a countermove. She wants all her cubs to have a fair shot, not for one giant cub to hog all the resources. So, her genes have evolved to pump the brakes on that explosive growth. She passes on growth-inhibiting genes that keep things in balance. In a normal lion-lion pair, this genetic tug-of-war between grow and slow results in a perfectly normal-sized cub. Tigers are a different story. They're solitary. A female tiger usually mates with one male at a time. Without that intense competition among cubs from different fathers, they never evolved the same genetic conflict. The male tiger's grow gene isn't as supercharged, and just as important, the female tiger doesn't have the powerful growth-inhibiting brake gene that a lioness does. So, when a male lion mates with a female tiger, you get a genetic mismatch. The lion father passes on his powerful grow big and fast genes, but the tiger mother doesn't have the corresponding slow down gene to counteract them. The genetic brakes are gone. The result is abnormal overgrowth. and the Liger cub just keeps getting bigger, far beyond the size of either parent. This also explains why Tigons are smaller. With a Tigon male tiger, ex-female lion, the tiger father gives a standard grow gene, but the lioness mother still passes on her very powerful slowdown gene. With a standard accelerator and a powerful brake, the Tigon often ends up smaller than its parents. It's all about which parent passes on which evolutionary strategy. This brings us to a critical point. Ligers are not found in the wild. They are a product of captivity, created when humans put lions and tigers in the same enclosure. Historically, the territories of Asiatic lions and Bengal tigers did overlap in India, but their different behaviors and habitats, lions in open grasslands, tigers in solitary forests, would have made a natural meeting extremely rare. They are separated by both geography and lifestyle, making the liger a distinctly man-made animal. The history of breeding these hybrids goes back to at least the early 19th century in India, often created as attractions for menageries. Today, while there is no official census, it's estimated that around 100 ligers exist worldwide, almost all in private zoos or sanctuaries. Their rarity and size have made them objects of intense public fascination. While the science is fascinating, the reality for ligers is controversial. Their gigantism isn't a sign of strength. It's a form of abnormal growth that can come with a high price. Ligers are prone to health problems related to their size. The rapid and excessive growth puts immense strain on their hearts, joints, and organs. They can be susceptible to obesity, arthritis, and neurological issues, and some may have shortened lifespans. The birth itself can also be risky for the mother tiger, whose body isn't built to deliver such massive cubs, and may require a C-section that endangers her life. The genetic rules of hybrids also come into play. Male ligers are sterile and cannot reproduce, which is a common outcome known as Haldane's rule. Female ligers, however, are sometimes fertile. They have been bred back to lions or tigers, creating even more complex hybrids, sometimes called ligers. This only deepens the ethical debate, creating animals even further removed from nature. The liger forces us to think about our role in the animal kingdom. Just because we can create these animals, does that mean we should? What's our responsibility to the creatures we bring into the world? We want to know what you think. Let us know in the comments if you see ligers as a scientific marvel or an unethical practice that should be stopped. And if you enjoyed this look into the wild world of genetics, be sure to like, subscribe, and hit the bell so you don't miss our next video. The liger is a living, breathing example of genetic complexity, born from an evolutionary mismatch, a growth accelerator with no brake. Its huge size isn't a myth. It's the predictable result of a genetic conflict between lions and tigers that plays out when they are bred together. But the liger is more than just a scientific curiosity. It represents the blurred line between the natural world and human intervention. Their size makes them famous, but their health problems make them controversial. They are a powerful reminder that bigger isn't always better, and that when we hold the power to create new forms of life, we also hold the responsibility to consider the consequences. The story of the Liger makes us ask not just if we can, but if we should.